Thomas, for your kind words. It's the time now. Good morning, everyone. Welcome to the Innovation in Linguistics talk series raised by Cognitive Semantics Journal. Today, I am thrilled to host the 12th lecture in this series. And before we begin, I'd like to provide some background information of our journal. Just a quick view. Cognitive Semantics is a peer-reviewed international journal focused on exploring the intricate relationship between meaning and the mind. We welcome submissions of unpublished research from all theoretical strands within linguistics. Here are the editors of our journal. And here are the editorial assistants. As we mark the 12th lecture in our Innovation in Linguistics series, you can find information about our previous 11 lectures and watch their recordings either on our WeChat platform or on our YouTube channel. A good news to share with you all is that recently the 2023 JCR was released, and we are happy to announce that cognitive semantics is included in the Q3, and we have an impact factor of 0.5. Today, we are honored to welcome Professor Dennis Day. Professor Dennis Day is a professor of linguistics at Nanyang Technological University. He is trained in linguistics and computational mathematics. His research interests include cognitive linguistics, metaphor theory, mental health care discourse, and applications and pedagogy of data analytics, machine learning in the humanities and social sciences. He is co-editor-in-chief of Metaphor and the Social World, associate editor of Metaphor and Symbol, and a co-series editor of Bloomsbury Studies in Language and Healthcare. The topic of today's lecture is Metaphor for Machine Learning Pedagogy Beyond Cognitive Dimensions. So without further ado, I hand over the floor to Professor Dennis Day.
Thank you very much, Leona, for your kind introduction, and to Thomas and also your journal for organizing this very meaningful series. So let me share my screen first. Okay, can everyone see my screen?
Yes.
Okay, great. So thank you everyone for attending my talk on a Saturday morning. Right, thanks for taking the time out to do so. So today I want to talk about applying metaphors for educational purposes, pedagogical purposes, in a fairly recent burgeoning field of recent interest, which is machine learning, which is increasingly, I would say, important and salient even in humanities degrees programs. And I want to talk about metaphor as it is used not just in the prototypical cognitive sense. As we know, conceptual metaphor theory, typically characterizes metaphor as a kind of cognitive bridge, right, between the abstract and the concrete. I also want to talk about other aspects which are potentially relevant to pedagogy as well. So I hope to speak for about 1.5 hours if possible, and then we will leave some time for discussion and Q&A, and your comments are very much welcome. Right, so the outline for today's talk. First, I want to quickly introduce, for those who may not be aware, what machine learning is and its growing importance in humanities education, which gives us many unique opportunities for research into the pedagogical aspects by combining, metaphor theory, linguistic theory and things like that. Okay, and then I want to give a quick overview of existing pedagogical research on metaphor, right? How metaphor is used as a pedagogical tool in various contexts, highlighting the fact that most of this research has been focusing on the cognitive dimensions of metaphor, and therefore it would be good to go beyond that, to look at also things like motivation, interaction, and things of that nature. And I identified 4 overlapping domains of inquiry that researchers can pursue, right? And following that, I will go through some recent studies of mine, which employ multiple methodological approaches to address some of these domains of inquiry. And finally, finish up with some pedagogical implications, which from a synthesized point of view, point towards the fact that metaphors can help the pedagogy of machine learning. Okay, so what is machine learning? It's essentially a key component of AI and data analytics, right? So machine learning deals with algorithms or something like logical procedures, step-by-step procedures that are generalizable and can help machines, which in most cases mean computers, right, learn patterns from large data sets, and then based on these patterns, generate some predictions, or in some cases, even take practical actions, right? And the key point here is that it does so without being explicitly programmed to do so. So for instance, taking the latest example of, let's say, a self-driving vehicle, right? So machine learning helps the car drive in different situations, but each of these situations doesn't have to be explicitly programmed into the car, right? Rather, it's a set of general mechanisms or instructions that a car can so-called learn and then reproduce, right? So that's the basic understanding of what's machine learning. All right, so some examples more in the domain of linguistics or applied linguistics. For instance, we talk about different types of learning, but we have supervised machine learning, we have unsupervised machine learning, right? Supervised machine learning is where we supply the computer with labels or with some so-called answers, and we supply them with predictors such that the machine can connect the predictors with the answers and then generalize them, right? So for instance, linear regression is one of the most common machine learning algorithms. And a sample application in linguistics would be, for instance, in applied linguistics, we predict test scores, which is the outcome or the answer, using various kinds of demographic data of students, which is the predictors. Another example is k-nearest neighbors classification, right? Or KNN for short, right? Whereby we also do predictions, but predicting categories rather than scores. So for instance, in a literary studies paper using machine learning, we can predict the genre of the novel using various stylistic features of the text. And we also have unsupervised machine learning, where the machine basically looks at a bunch of data and figures out patterns by themselves. So we don't have to supervise the machine, hence the name. So one of the most common algorithms is something called k-means clustering. And an application would be, for instance, in the field of linguistic typology, where we simply provide the computer with various kinds of linguistic and speaker data that characterize certain varieties, and then the computer can discover natural groups of these varieties based on similarities in the input data, right? So that's machine learning, and this is an entire field. Of course, this is a very simple introduction. So the entire field of machine learning is devoted to inventing and also optimizing these algorithms, right? And the reason why it's getting increasingly important is because it is actually a type of AI. And of course, AI is a buzzword nowadays. Why is it AI? Is because we are exactly training the machine to do human things like these, right? Without actually explicitly telling them how to do so. Okay? So as I mentioned just now, part of the motivation of what I'm doing is precisely because in the humanities, there is a growing presence, especially in linguistics programs. And I guess most of you can guess the reason why. It's because of NLP, right? Natural language processing is a very key pillar of AI and machine learning. So therefore, a lot of linguistics programs, including the programs that I am teaching in right now in NTU, as you can see, as well as the program that I recently taught in PolyU, which I just recently left, right, in Hong Kong. We also have programs that train humanities students. For instance, this is a Bachelor of Arts in English and Applied Linguistics program with a secondary major in AI and data analytics. So, and I'm sure in China, there are programs like that as well. If not already, then slowly and growing, I'm sure. Okay, so but from the researcher's perspective, it gives us many unique opportunities for research and applications. So for instance, how to train humanities students who may or may not have, most likely not, right, have the technical background in the most optimal way so that they can understand and apply, right? So in terms of curriculum design, there's a lot of research gaps. In terms of attitudes and perceptions, there are also gaps, like a recent study I've done, which I tried to probe into the perceptions of linguistic students towards data analytics and programming. Programming is a very important component to implement the data analytics and machine learning. So I happen to teach these kinds of courses. So therefore, from my personal perspective, it has given me a lot of opportunities to do this kind of research, right? And for today, I want to talk, of course, about the pedagogical strategies, of which metaphor, as we all know, as linguists, right, is a cognitive phenomenon, is a linguistic phenomenon, and therefore various ways to frame or to conceptualize or to impart data analytics and machine learning concepts using metaphors, which may help humanities students acquire the concepts. Okay, so existing research is not lacking, right? A lot of work has been done on how metaphor in general can help pedagogical applications in various domains, especially in science education, right? Because we all know that scientific concepts, a lot of them tend to be metaphorically, if not conceptualized, then at least packaged and presented to novice audiences. And a lot of this research, unsurprisingly, has been influenced by cognitive theory, conceptual metaphor theory, which claims, as you can see on the diagram here, that essentially you have a conceptual mapping, right? Some people call this analogy, but for our purposes, it's interchangeable with conceptual metaphor, for example. Okay, so there are cognitive bridges, right, that kind of like portray a certain target concept in terms of a source concept or an analog concept, right? And what happens is that there is static and unidirectional source to target transfer of inferences. So that's the fundamental premise of conceptual metaphor theory, right? That is unidirectional. That means inferences flow only from the concrete to the abstract. And also very importantly, it is static, which means that it is kind of like a fixed conceptual schema, okay? And this is very important when we explore the limitations of this kind of view, okay? And presumably conceptual metaphors are most ideal when the target knowledge is limited. Because if the target concept is limited, that means students don't know much about the target concept, then we are basically in a situation where the source concept doesn't have any interference, right? So the source concept can shape the target concept in optimal ways. Okay, so that's basically the most research focuses on this kind of approach, right? As a result, there are some underexplored aspects which I want to talk about today. For instance, the relationship between metaphor use and affect or motivation or emotion is underexplored, right? How metaphor facilitates classroom interaction or interaction between teachers and learners is also underexplored. How students produce metaphors and not just use metaphors as a learning tool is also underexplored. And importantly, for our purposes, because we are dealing with humanities students, they may have a higher meta-linguistic awareness of what metaphor actually is. So that actually plays a role in the process, because if the students know what the tool is about, they may look at it in a different way than if they don't really know or don't really care what the tool is about. Because this may distill certain critical perceptions that are also underexplored as to the limits or perhaps the weaknesses of metaphor use. So I want to talk about these things today. Right. So why humanities? Right. As of course, one of the most basic reasons is because we are all, presumably most of us are in the humanities. So that's our cup of tea. And also the more focused question is, what makes humanities students interesting from a research point of view? So why is my talk today, why are my studies focused on humanities students, right? So these pictures show me, right, teaching data analytics and machine learning in various different contexts, right? So to kind of like high school students who sign up for some kind of training camp at university, to international students in international schools, and to Chinese students in my most recent job in Hong Kong, right? So across, they are all humanities students, but across all these different settings, we can find some characteristics that make them particularly interesting from my point of view. First of all is that they seem to be more willing to interact in class compared to students from other disciplines. And this is very important because this allows us to test the interactive dimensions of metaphor, okay? And they're also more willing to interact with teachers, okay? And there is usually a diversity of attitudes that I've personally observed from experience when it comes to teaching machine learning or statistics or data science, this kind of stuff, right? You can see from these pictures yourself, right? So you have very, very engaged students, for example, on the right. These are actually doctoral level students, right? And as you can see, they are very, very focused on their work, on their programming task. They are very engaged, But you can see this guy here, he's nodding off, right? He's sleeping. So probably because my teaching is not that good, right? But also another possible reason could be that he's just not interested. He might be thinking, this doesn't, why should I learn this kind of stuff, right? So this diverse attitudes is also an interesting spectrum for us to explore as relates to metaphor use, as we will see later on. And lastly, and most theoretically speaking, there is this very interesting tension, because on the one hand, not to overgeneralize, right, but most humanities students can be considered like a blank slate in terms of data science or machine learning, simply because they haven't had prior experiences with these things. So therefore, in a sense, they are true novices, right? If you remember, according to previous research, right, metaphors are most effective when the learners are novices, because they don't have the target concept in mind, right? But then on the other hand, because they are humanities students, especially linguistic students, there's a high probability that they know what metaphor is, at least heard of it, right, in their studies. So there's a high probability that they have some kind of meta-linguistic awareness of metaphor. So how this actually so-called, interacts or interferes with the fact that they are a blank slate when it comes to the target domain is an interesting point of departure, in my opinion, for pedagogical research on metaphor. Okay, so I can identify 4 domains of inquiry, right, which allow us to go beyond just looking at metaphors cognitively into other aspects, and they're overlapping, right? So I call them representation, affect, production, and interaction. Okay, so I only have time to talk about these 3 below today: interaction, affect, production. Representation, maybe another day. Okay, but representation will be asking the question of how do we metaphorically frame ML? ML stands for machine learning, right? In ways that support creative pedagogy, right? So for instance, something like linear regression, how do we talk about it metaphorically that are in a way that is interesting? Okay, that's representation. Okay, affect is asking a broad question like, does metaphor help learners feel better in a very general sense about machine learning? When I say feel better, I include various things like motivation, interest, and stuff like that. Production, can students move from just comprehension? Because a lot of times, the assumption is that we use certain pedagogical strategies from a very comprehension point of view, right? Students are taking it in. But can they move from comprehension to production, construction, or sometimes co-production and co-construction with fellow learners or even with teachers of metaphors? Okay. And then finally, interaction, does metaphor promote learner-teacher interaction and engagement, right? So these are the questions I will be asking today, or rather answering today. And of course, I'll talk about the combined pedagogical implications towards the end. Right, so my talk today will be based on several recent as well as ongoing studies, because I believe in evidence-based implications, right? So these are some studies that I will draw upon today. Each of them focuses on a different aspect, right? And you may look at these if you're interested later on. Okay, so let's take a look at the first study, which tries to answer the question of how different metaphor types, right, can influence competencies and attitudes of students who are learning machine learning. Okay, so metaphor types are actually, we can think of them as discourse models, right? They are models for discursively constructing metaphors. And these models are drawn from psycholinguistic models of metaphor processing. Okay, so 2 of the most common models or 2 of the most common metaphor types are what I call correspondence model and the class inclusion model. Okay, so the correspondence model, or CO, draws from cognitive linguistic models of metaphor processing, which essentially emphasizes there is a source, there is a target, and we want to juxtapose or put side by side source and target elements, because people are mapping these elements from source to target, and they're also drawing inferences from these mappings. Okay, so one of the most common pedagogical examples is the Rutherford model of atomic structure of the atom. As all of us will know, right, from high school or even primary school, we know that the atomic structure of an atom can be compared to the solar system, right? Whereby, for instance, the nucleus of the atom is like the sun of the solar system. The electrons that orbit the atom are like planets that orbit the sun. And the force that keeps the orbiting going on is known as the orbital force. And in the solar system, it's basically gravity, right? So this is a model, and if we construct it discursively to make it a teaching material, then we will focus on things like verbal and or pictorial or even multimodal depiction of some kind of clue that helps students connect the nucleus to the sun and so on and so forth. For instance, you can draw pictures and so on and so forth. So this is what I call a CO model of constructing a pedagogical metaphor. Okay. On the other hand, the other extreme is what we call a CI model, class inclusion. And this is influenced by people like Glucksberg and McGlone, right? Who argue that metaphor is not a matter of mapping, but it is actually a matter of superordinate categorization, right? So for instance, I don't know how many of us have watched Forrest Gump, right? A very famous movie in the 90s. And the lead character likes to say life is a box of chocolates, right? Because you never know what you're going to get, okay? So in this kind of metaphor, instead of mapping life to chocolates, for example, I don't say, oh, the chocolate corresponds to something. I don't say the box corresponds to something. That's not the point of the metaphor. The point of the metaphor is to say that both the source and the target are actually examples of a more abstract category called unpredictable things. Okay, so therefore, if this is how we process metaphor, we can also construct metaphors in this way, whereby you have a target domain, like for example, machine learning. You find a kind of source, and instead of emphasizing the mappings like these, you try to emphasize on the superordinate principle in order to convey the point. Okay, so in the Forrest Gump example, life is like a box of chocolates because you never know what you're going to get, right? So this is like the punchline, and this is like the superordinate category. Okay, another example is something like life is a journey because they are both full of excitement and opportunities, something like this. Okay, so we emphasize the superordinate category. So I want to find out what happens if I compare two groups of students, and in one group, I use the CO metaphor type, and in another group, I use the CI metaphor type. I teach them the same thing, and I compare their performance and attitudes afterwards. So that's the basic idea of study one. Okay, so I did this study, and as part of an elective course, right, for humanities students, right? So the concept to be taught was regression, or ordinary least squares regression. So the idea, I think some of us are very familiar with it. So we try to predict the outcome by drawing a linear line that minimizes the distance between the data points, okay? So from a data analytic perspective, the concepts that are important would be something like the total sum of squares, right, which is the total variation in the dependent variable. The regression sum of squares, which is basically how much variation does your model explain? And then the error sum of squares, which is basically the residuals. That means basically it's A minus B, okay? So this is the target concept to be learned. And they also need to know how to calculate it manually, right? Okay, so then my question is, if I teach this using metaphors, how do the different metaphor types impact the assessments, which is a measure of competence, right? So there are two assessments. One is manual calculation. I will show you later on. And one, I told them to write a short essay about how regression analysis like this can address a practical problem, okay? And I also examined their attitudes towards regression. I did a survey on how they perceive whether regression is useful and how it helps them in their personal growth. So these are validated surveys, as I will show you later on. Okay, so this is the stimuli. So as you can see, I summarized them, right? The actual stimuli consists of PowerPoint presentations and stuff like that, which is, we don't really have time to go through so much detail, right? So on the left, you have the CO strategy. As you can see, the idea here is we try to conceptualize regression analysis in terms of dots and lines in physical space, okay? And then the way the metaphor here is constructed, as you can see, something like this. Each dot on the scatter plot represents a student. So a very clear mapping from source to target, and a very clear linguistic signal represents, okay? The distance between the dots, therefore, represents how different their scores and study hours are, The further the distance, the greater the variability. So to save time, right? Essentially what I'm trying to drive at is that I'm trying to communicate or to construct this pedagogical metaphor in terms of a very schematic CO structure, whereby there's always source represents target and then explaining the mapping. So this is the CO condition. The CI condition, as you can see, is a different metaphor. It is helpful to visualize regression in terms of a radio station broadcasting a signal. Okay, so in this metaphor, instead of mapping A and B, I'm trying to tell the students that doing regression is like being a sound engineer, because like a radio station, when you broadcast a signal, it actually contains certain noise. So that when you sit at home, you listen to the radio, the eventual signal you hear actually is filtered, right? Because the sound engineer will try to eliminate the noise in the signal. So likewise, in regression analysis, the final model is basically trying to reduce the noise in the data. Okay, but the way I construct the metaphor is, instead of doing this pattern, I use the CI pattern, where I elaborate the source domain, in this case, the radio station, using a whole paragraph. I state the overarching principle, and then I elaborate the target. Right, so I hope you guys can see these two are different discursive constructions of metaphor, and they have different effects on learning. Okay, so results, right? So the test of competencies consists of two parts. The first part, they need to do a manual calculation. So this is the test script, right? I gave them this example, and then I told them to calculate the SST, SSE, SSR. Of course, I taught them the formula before that. Okay, so students who are exposed to this one and this one, how do they perform in manual calculations? Okay, and what I found was that students exposed to the CO strategy outperform the CI strategy. Okay, so the mean difference is significantly different. Okay, so how I explain this is, perhaps if we present a metaphor via systematic source to target correspondences, we are emphasizing localized details, the nitty-gritty, over the bigger conceptual picture. And this kind of approach may potentially be better for tasks like systematic manual calculations. Whereas on the other hand, CI does not actually impart a clear inferential structure or clear inferential logic that is able to dovetail with the requirements of the calculations. Okay, so this could be why students exposed to this kind of source target correspondence instruction are better able to do the calculations. Although strictly speaking, there is no connection between the metaphor and the mathematics, but yet we observe this difference. So that's quite interesting. All right. And then the second assessment is an essay. So because, humanities students are better at writing essays usually, right? So therefore, one of the assignments was an essay question, which is identify a realistic question in your future work or research that could be addressed by regression analysis, okay? And then explain how regression analysis would apply and how it adds value to conventional ways of answering the question, okay? So this is the rubrics. And in this assessment, interestingly enough, the results are reversed, okay? The CI group now outperform the CO group, okay? So how do we explain this? Why is it that students exposed to this kind of box of chocolates structure is better at writing essays than this kind of metaphor, and vice versa? Okay, I think one possible explanation is that because the CI metaphor actually spotlights the overarching point, so it facilitates assessment outcomes that correspondingly focus on appreciation and extension of general principles instead of localized manual calculations. And both these aspects are important to become a good machine learning person or practitioner. So both aspects are important. So for instance, one of the best essays I saw is like this, right? So regression could be used on socioeconomic measures like income and education to predict voting preferences. So this student is saying, we can use regression to test or to kind of predict who the people will vote for, okay? Because it prevents more influential people from making their opinions louder than others. And that's a very good point, because from a regression perspective, each data point is supposed to be equal in status, okay? which is something like a bad model with a lot of noise. So this student is able to extend the inferential logic of general principles onto his essay, okay, compared to students exposed to this kind of condition. Okay, so that is for competencies. Okay, what about attitudes, right? So for attitudes, I drew from the survey that is constructed by Jordan and Haynes, right? Specifically, just two constructs which aim to measure how students feel about the practical utility of regression. For example, regression will help me learn other subjects. Regression helps me understand the world around me, blah, 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 blah. And they rate from 1 to 7. Okay. And the other construct is personal growth. Okay. Doing regression helps me understand myself, blah, 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 blah. I can be creative. It's about my personal growth as a person. All right. So what I found was, okay, there are no statistically significant differences between the CO group and the CI group, okay, in terms of the mean survey scores. Okay, so on a 5-point scale, right, whereby 1 is strongly disagree and 5 is strongly agree, right, you can see these are the mean scores. And there's also no significant differences in terms of practical utility. So in other words, it doesn't seem to matter what strategy I use. Students rate these two things sort of similarly. Okay. However, if you want to really dig deeper, you can observe that the CI, which if you recall is the box of chocolates kind of strategy, focusing on the principle rather than the mappings, right? In CI, there was more strongly agree answers or people, right? And there were no cases whereby they strongly disagree. Okay, whereas in CO, there are some strongly disagree cases in dark red, and there were fewer strongly agree cases in dark blue. But of course, this is not a statistical analysis. Okay, so for example, because students were also invited to give open-ended comments if they wanted. Okay, so students in CI said something like, regression is like a general tool used not only in science, so I think it is worth learning. Okay, it is interesting that so many different things can be connected by applying regression. Whereas in the CO group, you see people starting to say things like this, which we'll go a bit more into later, right? It is difficult to remember what the dots and lines mean. So I don't really know what it has to do with language. Okay, so it's a very interesting point of view, which I will talk about more later on in terms of how motivating certain metaphors are. Okay. So I also correlated personal growth and utility, just to see whether or not people who found it useful also found it beneficial for their personal life. Okay, so not very surprisingly, both ratings are correlated significantly in both CO and CI groups. Okay, so students who found regression useful also found it helpful for their personal growth. Okay, however, if we look more deeply into how performance correlates with personal growth and how performance correlates with utility, performance here means the scores of the students. You see that in CO is more strongly correlated than in CI. Okay, so these are Spearman coefficients. Okay, so very interesting. Students who are exposed to CO, which is a very systematic metaphor, they tended to rate the usefulness of metaphor higher if their scores are also higher. Okay, so in other words, it is more performance driven. Whereas students in CI, right, even though some of them didn't do very well, they may still rate personal growth and utility higher. That's why it's weakly correlated. Okay, so that is interesting. And the way I explain this is because actually, if you look at a CO metaphor structure, it is quite reminiscent of what scholars call rote learning. That means memorization. Because if you look at this kind of metaphor, it's about, oh, source is target, source is target, source is target, mapping, mapping, mapping. Very systematic, but a bit so-called boring potentially, right? So therefore, I think in this kind of situation, in certain cultures, like Asian cultures, which value performance quite highly, it is quite likely that if you teach students in this way, they actually also find the material more useful for their lives. Okay, and at least this is what I found. Okay, whereas the CI metaphor doesn't emphasize memorization, it emphasizes meaning because you focus on the overarching theme, right? Life is like a box of chocolates. You never know what you are going to get, right? So in that kind of setting, it seems to be that attitudes of the students towards the subject becomes less linked to actual performance. So this is something for teachers to bear in mind. Okay, so the lessons learned from the first study is that there is no one-size-fits-all solution. So when we say we want to use metaphor for machine learning, you got to ask deeper questions, how you use the metaphor. Okay, so in existing research, metaphor is often seen as a generic pedagogical strategy, right? But then as linguists, as cognitive semanticists, as cognitive linguists, we know more about metaphor theory than the general metaphor, the general teacher, I should say. Okay, so therefore, we should use our expertise to think about strategic construction of the same metaphor in different ways. For instance, the CO way and the CI way, right? Given the same metaphor, if you are a metaphor expert, I think you'll be able to construct the same metaphor in a teaching material in very different ways, principled ways, right? And this, as my study has shown, actually can impact different assessments and outcomes. So if your intended learning outcome is more like manual calculations, then the CO metaphor seems to be more useful. But if your intended outcome is like a more general appreciation of general principles, then it seems that the CI metaphor is more useful. So therefore, teachers, all of us, right? And of course, all these things don't just apply to machine learning, right? Whatever your target domain is, perhaps these results may also generalize. I don't know. It's interesting to find out, right? So teachers should go beyond so-called textbook or so-called stock metaphors and try to reconstruct and communicate them using different strategies. So that's the first lesson we can learn about how to optimize metaphor use for teaching. All right, so that is the first study looking at the metaphor types and the impact on performance and attitudes. The second study looks at students' production of metaphor. And this is interesting because we seldom ask students to do this, at least not in mathematics education. We seldom ask students to say, give me a metaphor that can, capture your learning, for example. Okay? So this study is what I call creative target to source transformation. Okay, so I define target to source transformation as cases where the target domain in the discourse are creatively reappropriated as a source domain as the interaction unfolds. So this is actually my research on psychotherapy, which is also one of my areas of interest. So this is actually therapy sessions on victims of the New Zealand earthquake in 2010. As some of you may know, right, the Christchurch earthquake was the most devastating in New Zealand history, and it kind of like, unfortunately, took away the lives of more than 300 people. So we interviewed some of those survivors and asked them to talk about their experiences in a therapeutic setting. And you can see people say things like this, right? So the person says, the ground was still moving and we were in the dark. So this is actually a literal expression because what happens was the ground was really moving because it's an earthquake, and they were really in the dark because of a blackout that happened, right? The electricity was cut. So this is actually a target domain because, this is the target topic, right? The victims were talking about their experiences at the target. So notice that they didn't use any source domains. In other words, they didn't use any metaphor because all these experiences are already quite concrete. But very interestingly, they converted a potential target into a source. Because later on, they said, we were in the dark. The same person said, we were in the dark and didn't know where the future was heading. And now this becomes a source domain, as you can see, because now we were in the dark is actually talking about something like the future is light, or hope is light and despair is darkness. Okay, so this is what I call target to source transformation, which means in natural discourse, we have this kind of very creative wordplay involving metaphors. Okay, so actually, if you think about the context of education, not counseling, but education, such reappropriation or chaining, so this is a chain, right? So target to source. This kind of dynamics is actually quite typical in the education literature in contemporary theoretical models of learning. For instance, in Hattie and Donahue's model of learning, claims that, students come to the session with some skill, some will, some thrill. So they have some background knowledge, they have some motivation, they have some excitement, okay? And the teacher's job is to take them through the process so that when they come out of the classroom, these aspects are enhanced. That means I have higher skill, higher will, and hopefully higher thrill. But the mechanism, as you can see, involves some kind of training whereby we first teach them the basic concepts, surface level learning, and then give them some way to internalize, to consolidate, to capture the principles so that we have deep learning, right? And also give them some mechanism to transfer the deep learning to new situations based on perceptions of similarity or dissimilarity. So according to Hattie and Donahue, ideal learning goes through this kind of mechanism whereby one step scaffolds upon the other. So my argument is that metaphor provides this kind of transfer mechanism for students to transfer their knowledge of machine learning onto other aspects, as we will see. Right? So therefore, ideal use and management of pedagogical metaphor should have the following conditions, right? First of all, they should resonate with learners' skill, will, and thrill. In other words, they shouldn't be too difficult or unfamiliar to students. They should facilitate surface and deep learning through source target inferencing. So it is through metaphor that students move from surface to deep learning. And finally, after learners have developed some competence, it should provide a transfer mechanism. And what I want to see is whether or not students can do this by converting the original target concept, which in this case is regression analysis, right, into a source concept instead. And if you can do this, then they have proven that they have, reached this transfer stage because they can use metaphor in a non-static way. So conceptual metaphor theory argues that metaphor is static. But when we produce metaphors in creative ways, it actually kind of undermines this assumption. Okay? And also, importantly, because we use metaphor, we can convey a sense of pedagogical consistency. Because we use metaphor as both the input, we give students the metaphor here, and also in the output stage when we ask students to produce the metaphor. So this is a form of consistency in terms of the teaching material and the assessment material, which is important. Okay? So my question was, what are the nature and characteristics of learners' transformed metaphors? So when we ask students to produce a metaphor, what can we observe from the answers that tell us about the learning journey? Okay, so this is a qualitative study. So we got volunteers, and these volunteers are usually the so-called better students, right? From the earlier study that you saw, who are exposed to either the CO, which is the dots and lines metaphor, or the CI metaphor, which is the radio station metaphor, if you remember. So we ask students we elicit metaphors, right, from them, by asking them this question, right? We saw in the lectures that regression analysis can be compared to either this or that, depending on their condition. So we used this or that as a tool to understand regression better. Now that you have a basic understanding, shall we try to flip things around and use regression as a tool to understand something else? Okay. So now I'm asking them to use regression, which was the target concept, as the source concept for something else. So this dynamic is similar to the earthquake example, whereby we are converting a target into a source for something else, right? So notice in this stimulus design, importantly, we need to avoid mentioning metaphor. So we don't ask students, shall we use a metaphor? And we also carefully deconstruct what is meant by metaphor. And this is important, as I mentioned, especially for humanities students, because humanities students who may know what metaphor is, we don't want them to kind of like let the answers be affected too much by the meta-linguistic preconceptions. Okay? So I'll just share some qualitative results. So first of all, I want to share some expected difficulties. So it doesn't always work, right? There are actually some pedagogical impediments in the use of metaphors. And these difficulties are in terms of metalinguistic and metacognitive aspects. For example, some students just don't understand what I mean. Okay, so they don't understand this prompt, which is itself interesting. So sometimes when you do studies, you don't get a good answer. It's actually a good thing, because then you can talk about why or how the stimulus actually failed, right? So for instance, the student said, sorry, I don't totally understand what you mean by using regression as a tool. So you notice here, I asked them, shall we try to use regression as a tool? And what I really meant was, use regression as a source domain, right? So this person clearly doesn't understand. So I thought we use regression to predict values of data. What do you mean by using it to compare with something else? So in this kind of case, you see clearly metaphor is not really working. Okay. And some students are a bit critical. They question the usefulness of this activity. So why do we need to talk about or understand something else? I thought the course is about statistics and regression. So she's right, actually. So people don't see the value of this kind of, source to target transformation. And some students, in fact, there are only 7 students. So actually these are already 3, right? So 3 out of 7 students, right? So one of them gave a semi-coherent response. So understanding the question, but actually not quite understanding it fully, as you can see here. Okay. So here, the student doesn't really understand what I'm asking her to do, but nevertheless is able to give some kind of coherent response. So these are some food for thought for us. Okay. But nevertheless, there are successful cases. So for instance, this student said, arranging a time for friends to meet is like regression. So this student is able to look at regression now as a source concept and say, hey, when I try to arrange a time for my friends to meet, it's a bit like doing regression analysis. Okay, so the student, if you look at her answer, right, the green part is the target domain, the new target domain. The yellow part is the source domain, which is regression. Okay, so when I'm trying to arrange a time for friends to meet, it's something on regression. Interestingly, the diagram with the dots and lines you showed us, there is an explicit recall of original source. So when students transform the regression analysis into a source domain, they explicitly recall the original form of it as a target domain. Okay? And also in this metaphor, it actually preserves, excuse me, I'm having a okay. Hopefully I don't lose my voice. And in this metaphor, it actually preserves the inferential structure, which is the CO inferential structure. So as you can see very carefully, the student's response is also like target source mapping, target source mapping. So the student reproduces what she was taught in the original setting. Okay. In terms of discursive construction, as I was mentioning, we see a lot of source target juxtaposition, just like the CO example she was taught with. And also very interestingly, there is hedging and uncertainty. First of all, there is an overall hedging. At the end, she says, it's something like that. Am I correct? So she's not sure. And also at certain key junctures, whenever the mapping was explained, so you see words like maybe. Maybe different people are like this. Maybe it's like that. And these maybes tend to happen at spots where she's introducing an inference with the metaphor. And this kind of also echoed with a previous study I did, whereby psychotherapy patients also do the same thing. When they use metaphors, they will tend to express uncertainty at certain specific points. Okay. Second example is very interesting, right? This person says that
finding a life partner is like doing regression. Okay, I think regression reminds me of someone who wants to find a life partner, like a husband or wife. Okay, marriage is something of regression. So she says that the model is like a set of criteria you have for a husband. Different people you meet in your life are like the data points, and they're all different because different people are different. And then using the model, I can predict whether a new person I meet can fulfill the criteria I have. If he's suitable, he will be on the line. If it's not suitable, there will be an error. But my idea is not very clear, I think. Okay, so very interesting, right? Very similar observations. We see that there is an explicit recall of original source, the regression model you talked about. You see, you is me, right? The teacher. So you see, when students are asked to produce a metaphor, they are able to borrow from the original input knowledge. So when this happens, we are seeing a phenomenon according to the learning model whereby the input is being used to transfer to a new output. So according to the model, learning is taking place. Okay? And also, again, preserving the inferential structure and the discursive construction of the original metaphor. So the discourse construction here is very similar to the previous answer, even though they are different people. And it even ends also with something like, uncertainty. My idea is not very clear, I think. Okay. So again, we see that somehow something interesting is going on in terms of students' creative invention of a new metaphor. And then let's look at one example from the CI example. So both these students were from the CO group. The CI group is very interesting. This student says fortune telling is like regression. And why? Is because they both involve prediction. Okay, so maybe regression is like fortune telling, because fortune tellers will predict your future. They will ask for your data. I think she's talking about 八字 or something like that, right? In Hong Kong, there's a lot of, 八字, things like that. Ask for your 生辰八字, right? Personal information like date of birth, occupation, and so on. And then tell you a story about your future. Okay. But still, I think the two things are actually very different. Here's a very critical thinking, right? I don't think personal information can be considered data and so on and so forth. Fortune telling is not scientific and more like guessing. But regression is a very systematic thing and about finding patterns in data. So in this case, again, you can see, even though it's a CI strategy, there is an explicit recall of the original source, like that radio signal example you gave. Can you see? Okay. And again, there is very good preservation of inferential structure. And this time around, inferential structure is not source target, because remember, this student was part of the CI group. So instead, the way she constructs the metaphor is like both regression and fortune telling involves prediction. So this is the superordinate category. Remember? Okay. So this is like, if I were to go back much earlier, okay, this will be this kind of structure, right? Whereby fortune telling and regression are both examples of trying to predict things. Okay. So, okay, so you see here, there is an absence of source target juxtaposition. So the response is very different from the previous two students. The discursive construction emphasizes the class inclusive category, right? She emphasizes on the prediction and then talks about how the prediction is actually very different, because in fortune telling, it is like almost like, bullshitting or guessing, according to her. And for regression, it is scientific. Okay, right. And of course, there is also some hedging or uncertainty. But in this student, it's a bit less. I think this student is more confident. But she does say things like, I think, I don't think. So it's still a little bit of hedging. Okay. So very interesting. So if you look at these three responses, of course, it's a very qualitative small sample study, right? But if we were to synthesize these responses and look at how they reflect this mechanism, right? So remember when we do metaphor chaining, we want to examine how the original source, which is, this one, right? Remember the original source domain was either the dots and space diagram, which is the CO, or the radio station analogy, which is the CI. How it was used in step A, to map onto the original target, which is regression, right? And how the student converts the original target into a new source. So now regression is the source. And then in step B, map onto the new target. And in our examples, we have these three, right? Arranging time for friends to meet, finding a life partner, and fortune telling. And whether or not there's an overall relationship between the original and the new in part C. So what we can see from these three small studies is that across all three examples, the substantive content differ in A and B. So in all three cases, the student did not repeat this metaphor, which is good, right? Because if you just repeat it, then you are just throwing things back at me. Then you don't really learn anything new. Instead, these two things are very different from these yellow things, right? So that means that the contents differ, but importantly, the inferential structure is preserved. So even though the contents are differing, the underlying mechanism is preserved, as I explained just now, which therefore means that students are actually internalizing a learning mode. Okay, so the overall relationship C is therefore moderately strong, because although A and B are different, C is connecting all three. So therefore, the net result is that using this approach of creative transformation, there is a strong basis for the pedagogical consistency, because students are taught something, and in the end, they produce something that is different in important ways, but preserves the logic despite that. Okay? So I hope that is clear. So the lesson I learned from this study is that we need to achieve a delicate balance, on the one hand, between creative exploration, and on the other hand, technical soundness. Okay? So the student output shows that the static source-to-target structure of metaphor can be adventurously extended. So instead of ST, let's consider STS. That means, from source to target, and then from a target to a new source, thereby creating a metaphor chain. And this is in accordance with learning models like Hattie and Donahue that I showed. However, at the same time, there are some drawbacks and risks that are involved, okay? And these range from potential critical misunderstanding of the metaphor to unsound representation of target concepts. So for instance, we didn't really look carefully at the question of whether or not these answers, for instance, are actually technically correct. Okay? So there are some points where the student actually, for the sake of creating a metaphor, they actually distort certain things about regression. Okay, I won't go too deeply into why or how. For instance, in this example, right, actually prediction of new values is actually not really the same as seeing whether this person is suitable or not in terms of the mathematical logic. Okay, so this is a case where if we rely on it too much, we may risk actually unsound misrepresentation. And this needs to be carefully acknowledged and managed by the teacher. So on the one hand, we need to encourage creative exploration to facilitate transfer learning. But on the other hand, we need to pay attention into technical soundness, because especially for something like machine learning, it is very important to get the technical soundness correct. All right. So the first lesson was no one size fits all. Second lesson is balancing. What about our final study, okay, which is actually not published yet, right? So in this final study, I moved from attitudes, which is the first study, to production, which is the second study, to motivation and interaction, or effective engagement, and how metaphor facilitates or doesn't facilitate that. Okay, so effective engagement is a very pervasive construct in psychology. So it is about emotional and attitudinal aspects of learning, which include things like interest, boredom, happiness, sadness, anxiety, motivation, and so on and so forth. So it's an umbrella term that encompasses all these emotional constructs. So research has shown that effectively engaged students also exhibit positive behavior. And this is almost like common sense, right? But, you know, there is evidence that it is true, like focus, attention, initiative, and classroom interaction. So there is a reason to explore this hypothesis, right? So previous research on how metaphor enhances effective engagement has generally shown, for instance, how metaphorical framings of, for example, academic identity can instill motivation and confidence, okay, in learners, done through things like surveys, okay, and also through things like elicitation studies, right? For example, in the context of ESL writing, okay, asking students to use metaphor to describe their experience can change their beliefs about ESL writing, all right? And also things like discourse analysis, right, by Lynn Cameron, does a lot of work on classroom metaphors, also showed how they mediate learners' perceptions, okay? So all these studies have already shown that metaphor does contribute to positive effective engagement. So then why do I need to do anything else? Because I have observed some limitations in existing studies, right, which can be summarized in 3 interrelated themes. First of all is that some of these studies are non-naturalistic. For instance, in experimental surveys and so on and so forth, they may not reflect natural classroom interaction because you are basically constructing, right, a scenario. So this one is quite a typical criticism of experimental research. And also, more importantly, perhaps, a lot of these measures are self-reports that are consciously made. So for instance, if you ask a student, what do you think about metaphor? You ask a student, what do you think about your ESL writer beliefs? Then there is this potential for response and interpretation bias because they are consciously reflecting on the experience rather than undergoing the real experience at that moment, okay? And they are the ones who say yes or no, okay? And then finally, also relatedly, this issue about the fact that these measures are delayed, okay? The measurements of all these studies are made only after the metaphor use has occurred, which incurs potential recall bias. So for example, you know, this Lynn Cameron study, right? Discourse analysis by definition cannot happen in real time, right? You look at the transcripts, but it's already afterwards. And elicitation studies, right? Asking students to share their metaphors 1 week after, 1 day after, 2 minutes after, whatever the case may be, is not live. So it's a delayed measure which may incur potential recall bias. So what are some ways to overcome all 3 potentially? So therefore, there must be some ways that allow us to capture live responses. That means how the person feels about metaphor as it happens in real time, not 1 minute later, 10 minutes later, 2 days after. Spontaneous, which means it is something that they cannot really plan, right? It is not a planned response, it is a spontaneous response. And perhaps most importantly and most underexplored is this idea of unconscious measures. That means students are not able to control their response. So for instance, if my favorite teacher uses metaphor and you ask me afterwards whether I like metaphor or not, I would say yes, because I like the teacher, right? So therefore, that is an example of how it is both not live, not spontaneous, and also not unconscious. It is conscious. I'm reflecting on the fact that I like the teacher. But there must be some ways to do this so that we capture so-called authentic responses. And the answer lies with skin conductance or electrodermal activity, which is a physiological methodology. Okay, so again, moving into a different field slightly, right? Skin conductance is a measure of how well the skin, our human skin, conducts electricity. So in case you didn't know, actually the human skin is an electrical conductor. So that's why some of us can get electrocuted, hopefully not, right? So of course, the current that it can tolerate is not high, right? Maybe 10 amperes. Beyond that, you may just die, right? So conductance is a physical construct, right? It is defined as the inverse of resistance. Okay, G is like the symbol most physicists will use to signal conductance, which is the reverse of resistance. Resistance is how well you block electricity. So it's the reverse of that, right? So importantly, skin conductance is unconscious. That means we cannot control how well our skin conducts electricity. If you can, you are an X-man, right, or X-woman, okay? And it is non-volitional, okay? Or sorry, non-volitional means you cannot control. Unconscious means it happens without you realizing it. Yes? Sorry? I heard someone talking, so I wonder, okay, if there's nothing wrong, then I'll carry on. Okay, so, right. So where was I? Sorry. Okay, so it's unconscious, non-volitional, and the unit of measurement for conductance is called microsiemens. And it is basically the inverse of a mega ohm. Okay, ohm is the SI unit for resistance. So microsiemens is a quantified measure of how well the skin or anything else conducts electricity. Okay, so skin conductance has been shown to be a very reliable psychophysiological marker. Why is it psychophysiological? Because it contains both emotional characteristics and also physical characteristics. So psychophysiology, right? Psychophysiological marker of affect arousal. Affect arousal means how effectively aroused or engaged you are during interaction. So for example, if I'm sitting down here talking to you guys and suddenly behind me, someone, pats me on the back and surprises me. At that point of time, my affect arousal will shoot up because I am taken aback. I'm suddenly surprised. Okay. So likewise, if you are studying and a beautiful girl or handsome man walks past you, at least for me, right, I will look at, okay, I will immediately be drawn to that, and then it will also elevate my affect arousal at that moment. Okay, so what happens and how this is relevant is that actually, if we are aroused by a certain stimuli or if we are engaged by stimuli, our skin actually momentarily increases its sweat gland activity. So we sweat a little bit more when we are excited or aroused. And as a result of that, because of this increase in activity, our skin conductance also increases. So you see what I'm trying to drive at? So therefore, if we are aroused, to cut a long story short, our skin conductance will increase in a way that we cannot control and in a way that we don't realize. Okay? So we can measure this. We measure this usually in terms of two dimensions. Okay? SCR, skin conductance response, measures the change in change in conductance immediately after the stimulus. So we call this phasic skin conductance. So back to my example just now, if I am studying and someone attractive just walks by, that immediate spike is what we call SCR. Okay. Another way to measure it is a more long-term measurement, which is called SCL, skin conductance level, which is a more background and long-term average level. So going back to my example, if I see this person, my SCR will shoot up, okay? But if I wait another 5 minutes, okay, gradually it will taper down again, unless somebody walks by again, right? So therefore, SCL will measure more sustained engagement. So if your SCL keeps going up and up and up, that means something is going on that keeps you engaged. Okay, simple, right? So we measure this by very basic equipment. These are actually just electrodes you attach to your index finger, right? These are silver chloride electrodes that are able to detect the potential difference and the current that is flowing at your fingertips. And through a Bluetooth receiver, it is fed back to the computer. So by attaching this device to the teacher and the learner, we can measure their responses as they, do the lesson. So this is a typical output or a signal or wave or time series of response. So the higher, the more engaged, obviously, right? So you can see the beginning is a drop, right? And this part is usually where we ask the participant to wear the thing, but don't do anything, just sit back and relax, so that they will gradually obtain a baseline for that person. This baseline is different for every person, right? So then after the person is relaxed, we start the experiment. As you can see, it goes up and down, up and down, up and down, okay? So there are a lot of applications of SEL in different types of research. For instance, in communication studies, right? Media messages, a lot of scholars have examined how different kinds of advertisements arouse different kinds of responses, right? In psychotherapy, okay, myself, I have done quite a bit of work on testing how clients respond to certain communication styles, right? When they're talking about their issues, including metaphors, of course. Okay, and of course, there are also a lot of studies that show that these SELs correlate quite strongly with other kinds of responses, like heartbeat. Okay, what else? Heartbeat, finger skin temperature, maybe even eye tracking, things like that, right? So you know what is a lie detector, right? So when you're interrogated by the police, the lie detector is actually, part of it is actually skin conductance, okay? Because if you're lying, usually you will, spike up a little bit. Okay, so my study is to test if I were to use a metaphorical communication style versus a literal communication style to teach regression or machine learning, how do these responses differ? Okay, so I define these styles in my previous studies in the context of psychology as a metaphorical style is where the counselor guides a spontaneous co-development of something represented by a focused metaphor over time. So for instance, if I want to tell the client, don't think of your life as a black hole, think of your life as a journey, for example. So I don't just stop there, right? I will talk to the client, right? Think of life as a journey. And then I will invite the client to also contribute to the metaphor, right? Because we are spontaneously trying to co-develop it. So that is what I call a metaphorical style, okay? And of course, the literal style is the opposite, whereby I also talk about life, but I don't use metaphor, right? Or I don't use a focused metaphor. So sometimes I can have an occasional metaphor because, we live by metaphors, right? We can avoid metaphors, but we don't purposely focus on one of them, okay? So therefore, I can apply this same thing onto teaching, because actually teaching in many ways is quite similar to counseling. The counselor is like the teacher, right? So in a teaching context, we can have a teacher-guided, spontaneous co-development of a topic represented by a focused metaphor. So you use the metaphor to teach regression, you invite students to participate, blah, 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 blah. It's very similar to counseling. And likewise, the literal style will be, I teach the same thing, but I don't use metaphor, okay? So my research questions are as follows. First of all, does SEL, which is the long-term level, right, differ significantly between the two styles? Why do I look at SEL? Because, we don't want just momentary spikes, right? We want it to be sustained, right? And very interestingly, because I also measure teachers, right? So you can have two devices that are synchronized so that you can measure both teachers and learners. I want to look at whether their signals are in concordance. I want to see whether the signals are correlated. Because if the signals are correlated, it means when the teacher is excited, the student is also excited. That's a good thing, right? We can hypothesize that this will be a good thing to have when you're learning, because usually it's the other way around, right? The teacher is excited, but the students are playing with their phones. And when the students are playing with their phones, the teacher gets angry, right? So it's usually discordance rather than concordance. So I want to see if I use a metaphor versus if I don't use a metaphor, does this differ? Okay. And then finally, I also want to see whether or not the skin conductance measures, which if you remember is unconscious, cannot be controlled, do they nevertheless dovetail or correlate with conscious survey ratings? That means if I also give students a survey, I want to see whether or not students who exhibit high SEL also give high ratings. And this is a way for us to test the triangulation or construct validity, right? And then also, how do they reflect on their experiences in either style? So when I do this kind of study, I will always include some kind of qualitative part just to get some data to try to tie them together, okay? So let's have a look. So 2 styles, right? So the metaphorical style, I use the CO strategy. As you can see, it's multimodal, right? I kind of like depict each dot as a student. This is like a student's face, right? And I want to show them using the example of how we can use regression to predict exam scores from study hours. Okay. So the more you study, the higher you get for exams. Is that true or not? So we use regression to find out, right? So in my instructional material, I use a lot of metaphors as I showed just now, constructing it using the CO strategy. And then the control group is the literal style, which essentially teaches the same thing, but uses only literal mathematical concepts. Okay. So I did not compare the CI style, class inclusion style. Remember, there's another, because admittedly, this is because I don't have enough participants. All right. So therefore, I just focus on these 2, at least at the beginning. So how it happened was, first of all, of course, the students and the teacher relaxed first to get a baseline. And then the teacher gave a 5-minute short interactive lesson using either this or this. So what I mean by interactive is the teacher explicitly tells the students, feel free to interrupt me at any time, ask questions at any time, don't be shy, blah, 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 okay? So after the 5 minutes interactive lesson, I also allowed them a subsequent free interaction time. And this is to allow the students to ask more questions, because students, a lot of times, they are quite reluctant to interrupt the teacher, right? So therefore, 5 minutes plus however long they want to interact afterwards. But my recording will stop after 8 minutes. That means 5 plus 3. Okay. And this is simply due to practical reasons. Okay. And then I do signal processing, which is just something technical, scaling to make sure they conform to the same scale. Because different individuals can have different absolute measures of SEL. So you need to scale them to the same scale, usually from 0 to 1, right? Okay. So let's look at the results. So first of all, if we compare teacher and learner within each pair, because we have a teacher and a student pair, right? And we also compare across the styles. Okay, you can see the orange dots are the teachers and the blue dots are the learners. Okay, so interestingly, maybe not so interestingly, right? Expectedly, teachers' engagement is greater. You can see, right? In both cases, the orange line is more high above the blue line in the literal style. Okay, also in the metaphorical style, but only a little bit. Okay, so therefore, teachers' effective engagement is greater, and this is mostly likely because teachers are the ones that keep talking, keep focusing on the material, and students are like passively listening. Okay, but it is far more invariant between styles. Okay, so that means you can see that in both cases, right, there is actually an interactional effect, which means that the difference depends on the style. Okay, so to elaborate further, if you look at the main effects, as I already explained, the teacher higher than the learner, and this is not really good news for teachers, right? Hopefully it's the other way around, and when they're not playing with their phones, right? And also, if you just look at style, ignoring the learners, ignoring the role, right? Metaphorical style indeed is more engaging than literal style. Okay, the mean of the metaphorical style is higher than literal. Okay, And then you can see the most important result we have is the interaction, which is that teacher conductance is relatively stable across contexts. You can see the orange line, right? Whether it's metaphorical or literal, the average is about the same. And this could be due to teachers being experienced, right? They don't really, kind of like differentiate their own, or rather their own responses don't really get modulated so much by what they're supposed to do in different cases, right? But then, most importantly, there's a significant gain in conductance from L to M among learners. So among the learners, you can see in the metaphorical style, it is much higher than in the literal style. Okay. So this is what we mean by interaction effect, right? The gap between teachers and learners is much closer in metaphorical style than in literal style. Okay. And when we look at concordance, okay, so how do I measure concordance? So for each teacher and student pair, what I did was I simply correlated their signals. Okay, it's because this signal, right, the thing about this machine is that it can actually record about 175 recordings per second. So it's a very high frequency device. So over 8 minutes, you will get thousands and thousands and thousands of data points. And with all these data points, you can measure a correlation coefficient of each learner and teacher pair. So the higher this coefficient, that means the two signals are more synchronized, which is good. Okay. So therefore, we can see if we compare the coefficients of the teacher and learner pairs, the metaphorical pairs are much, much higher than the literal pairs. Okay. So teacher and learner affective responses tend to move in sync in the metaphorical style. And one of the possible explanations is that in the metaphorical style, it provides the source and the target correspondences provide what I call an inferential signpost. So when a teacher teaches about the target, moves to the source in a very systematic way, these specific points are anchor points upon which students can respond in sync. And when they respond in sync, I call that empathetic response. Okay? So to make this point clearer, I will show you two specific examples of what is a concordant and a discordant response. Okay? So these are actually the skin conductance responses that I showed just now. So this is like this one. Okay? So as you can see, it always fluctuates up and down, up and down. This is human nature, right? You never see a straight line because humans are always very, very volatile in terms of our affective states. Okay, so this is an example of a metaphorical pair. As you can see, the blue line is the teacher's signal. The orange line is the learner's signal. So you can generally see, right, these two signals will be quite strongly correlated because when teacher is going up, the student also generally is going up. Can you see? Okay. This part is the exception. Okay. In this part, in the middle part, you can see the orange line is going up, but the blue line is going down. But for the rest of the signal, it's in sync. Whereas on the right-hand side, you have a discordant style in the literal condition, whereby for most of the signal, can you see like 60 to 70% of the signal is moving in different directions. Okay, so all these are what we call visualizations of your affective state in real time. Okay, so after that, after showing how unconscious non-volitional responses are different, I also gave them a survey which is taken from the most widely used SATS 36, Survey of Attitude Towards Statistics. Okay, so I picked 6 questions. I will like statistics after the lesson, right? I will feel insecure when I have to do statistics problems. I get frustrated, under stress, enjoy, scared. Some of the scales, some of the items are reverse scaled purposely, right? Okay, so this actually are also measuring their affective attitudes. And I want to see whether or not the survey ratings correlate with the skin conductance ratings. Okay, so overall, as you can see, for all 6 questions, not for all 6 questions, or most of the 6 questions, as well as overall mean, the metaphorical style is indeed much higher That means students under the metaphorical style, they actually gave higher scores for this. Okay, except for question 2, which is the reverse. Okay, so therefore, metaphorical style learners, they reported liking statistics more. They feel less frustrated, less stressed, able to enjoy courses more, and feel less scared. But question 2 is about security when doing actual problems. And in question 2, literal style learners actually feel less insecure when they have to do statistics problems. And this is super interesting because my interpretation of this result is that students are actually aware that the metaphors are ultimately only models that approximate knowledge. Okay, so even though I didn't use the word metaphor in the class at all, but students can see that, you know, when I present the dots and lines using, you know, the pictures and all that kind of stuff, right? What I'm doing is I'm trying to only model the real, so-called real knowledge. And if students only have this model, they are scared, they are insecure that they cannot do the real problem compared to the literal students. All right, so this gives us a very important caveat about the potential limitation of metaphor. Okay. Okay. This is correlational analysis. So basically, I correlated the survey ratings with the skin conductance ratings. Okay, and for both groups, yes, they are correlated, which suggests convergent validity. Okay, yeah, and this, which means that students who answer the surveys higher also tend to have higher SCR ratings. Okay, so however, this correlation is stronger in the metaphorical style. Okay, which again is not, the difference is not very big, but if you want to explain it, it could be because by using a metaphor, it is a salient instructional features to help students align both conscious and unconscious feedback, but not a very important point actually, because there's no real evidence for a big difference. Okay, and then lastly, I'll try to finish in 10 minutes and so that we can have time for questions, right? So I also gave a semi-structured interviews, right, with some guiding questions, very general questions like, so after the learning experiment, how do you feel about the lesson, how it was taught, right? How do you feel about the way the material was presented? Can you explain your responses to the survey items? Things like that, okay? So some major themes that I want to share. First of all, there are some so-called nice or expected responses, okay? So remember, these are actually delayed conscious feedback, which is what I criticized just now, right? So I nonetheless still looked at it to compare them with the unconscious non-volitional skin conductance feedback, right? So most students, you know, they gave answers like, oh yes, metaphor is better because, for example, the connection between the concepts and the example is clear. I can see that the data points each actually represents a person. So this student is talking about this diagram, okay? The data point actually, you know, iconically is represented by a human face, right? And I can understand why the line needs to be near data points for a more accurate model. So this is praising the metaphor, basically, okay? And then in the literal group, okay, someone says the lesson is hard to understand because there is no example to follow. Okay, I know there is an example of exam scores and study hours, but I don't know why we need to use regression on it. Okay, so this student is talking about this lesson, whereby I purposely focus on the formula, okay, because it's supposed to be a literal style. So these are like expected responses, which is okay, fine, okay, good, shows the metaphor is good, hallelujah. But, okay, interestingly, there are also some unexpected responses, which is worth critical reflection. For example, one person said, the teacher can explain the concept well, but I also think he needs to teach how to do the calculations and not just use a metaphor or pictures. And this is exactly why we see question 2 being rated lower in the metaphorical condition, okay? Or we won't be able to answer actual questions in the exam. And this is why I said I will feel insecure when I have to do problems, okay? So this answer exactly summarizes also what I discussed just now about the culture, right? So being exam-driven, exam-oriented, okay? it is important to supplement a mental model like metaphor with the actual calculations, right? Okay. I think he used some metaphors. So this person, can you notice this person again demonstrates meta-linguistic awareness of metaphor. Okay. Although I didn't ask them about metaphor at all, right? But some students know what metaphor is. So this is again going back to my point about humanities students having meta-linguistic awareness. I think he used some metaphors in the lesson, which makes the concepts less clear because it is just a metaphor. So this is really, really a slap in the face, right? To everyone in the world who has ever claimed that metaphors make things more concrete, right? A very basic violation because some students actually think the reverse. Metaphors make concepts less clear because it is just a metaphor, okay? I still need to know what regression means. Okay, so this is a slap in the face to a lot of us, okay? And then another slap to the face. I feel the lesson is not really taught in a scientific way or mathematical way. Maybe we need some calculations or software to study statistics. Okay, so these responses really are sort of like, despite the experimental findings being positive, these kinds of isolated qualitative exceptions are very important for us to reflect on as teachers. Okay. And then another major theme is on the subject of meta-linguistic awareness of metaphor, right? There's a lot of variability. Some students know metaphor, what metaphor is very well. So you see, it was interesting to know that the relationship between scores and study hours could be statistically explained. The analogy of the students as dots, okay, metaphorically represent. That expanded my thinking and helped me see a mathematical thing in a different way. Can you see? So this is our model student who is the exact opposite of this kind of student, which talks about making the concept less clear. Okay, and this person brings in a lot of meta-linguistic awareness to talk about metaphor. Okay, and then the opposite is that this student says, I like it as the teacher is quite knowledgeable and enthusiastic, even though it is so short. So that means the 5-minute lesson, right? His way of teaching doesn't make students stressed. So notice this person is talking about way of teaching, but is unable to name it as metaphor. Okay, so there is a lot of variability. So when teachers want to use metaphor, they have to very carefully consider whether students know or don't know what metaphor is and how important it is. Okay. So, okay, second last slide. Okay, so the lesson learned from my third study is that metaphor does have tangible effects that can be proven to be not just a matter of delayed conscious response, but it's actually spontaneous, live, non-volitional, but only in appropriate doses. So don't overdo it. Okay. So sustained metaphor use leads to correspondingly sustained effective and collaborative engagement, right? Effective engagement is proven by the higher SEL ratings for students. Collaborative engagement is proven by the stronger correlation coefficient between teachers and learners. Okay, it is manifested immediately in the lesson as well as corroborated by the COSE class surveys. Okay, however, metaphor use is also associated with greater insecurity, as we saw in the question 2 in the survey. And if you probe further, students' nuanced responses are not always positive. So therefore, there is a need to carefully plan and communicate the intended ambit of metaphor use to students, right? So in conclusion, after taking you through the 3 different studies, I would conclude that metaphors can make machine learning more enjoyable and engaging for humanities learners, as long as we pay attention into C for customizability. As study 1 has shown, there is no one-size-fits-all solution. So teachers, especially teachers trained in metaphor, like all of us, must be prepared to consider that we can construct metaphors discursively in the teaching materials in different ways. And the different constructions may have an impact on the results. And we take into account A for agility, right? Study 2 shows that we need to be agile to know how to balance, on the one hand, between using metaphor to creatively show the students understanding. Remember, study 2 was about students' creative transformation of metaphor, right? On the other hand, when this creativity goes too far, there could be an undermining of the technical soundness of the student's answer. So how do we balance between that? It's a matter of agility. And lastly, N for naturalness. As study 3 has shown, metaphor has tangible effects, but just like any other medicine you take, don't take too much of it. Okay, only in appropriate doses. Too much of it makes students insecure, and therefore aim for the natural introduction and communication and elaboration of metaphors. So that is the end of my talk. Thank you very much for listening. I hope I took just enough time. So if you want to connect with me, feel free, right, on WeChat or Twitter or my email. And finally, these are some references I use for the study. So maybe I should stop sharing my screen for the Q&A session, right? Mm-hmm. Right, thank you very much.
Thank you, Professor Dennis Day, for this wonderful and impressive talk on metaphor and its application in machine learning pedagogy. And thank you very much for your wonderful work, especially the 3 case studies you present today. From my own perspective, your research into the pedagogy of metaphor is some of the most innovative and cutting-edge work in the field. The CI model with metaphors like the box of chocolate and the radio station, and the CO model with metaphors like source and target and dots and lines in physical spaces are particularly vivid and engaging. Usually, before we enter the Q&A session, I will briefly summarize your talk. But today, let's skip this because I can see in the chat that Tang Chuanhong already asked 2 questions, which I think are highly related to your talk, and we look forward to your answers. Thank you.
Sure, thank you. So, okay, let me take a look at the questions, right? So number 1, okay, thank you for your kind comments. Do we have tools to detect metaphor types for discourse analysis? Do we have any analysis framework to finish? Well, I think in general, right, the state of the art in the field is still to rely more on manual identification of metaphor than machine-guided identification, especially when you talk about something like metaphor types, because metaphor types, as I explained, is a very nuanced thing about how we construct metaphors strategically, right? So for instance, although I may be able to use machines to, for example, extract certain structures like source, target, mapping, source, target, mapping, I may be able to do that, but it actually really defeats the point because the whole idea here is about constructing metaphors in very creative ways. So that actually runs contrary to the idea of detection on a more general level. Although I can see that there are instances where this might be valuable, okay? But in general, I think when we talk about discourse analysis, we still need to rely a lot on text-guided contextual analysis. So I hope that's all right for question 1. You can always ask me more later on, right? Question 2, do you think different frequencies of using certain types of metaphors may unravel the user's thinking pattern for understanding the world? If yes, how do we Oh, this is a very profound question, right? So I think the whole idea about metaphor research is trying to see how metaphors reveal people's thinking patterns, right? So yes, I see your point. So you are going a bit deeper, right? So instead of just saying that metaphors help us understand people's thoughts, if you look more closely at how they construct metaphors, it does potentially, yes, allow us to see how in certain contexts, people prefer to understand a certain thing, right? So yeah, so for instance, if let's say in science, going back to the idea, right? In science, I hypothesize that you may find more CEO metaphors because people's intention is to ensure that there is systematic understanding. Whereas if you talk about philosophy, or maybe like Forrest Gump, right, a movie, Life is a Box of Chocolates, there is no point in finding, oh, this chocolate means your mother, that chocolate means your father. And that doesn't make any sense. Instead, it's more like finding the general philosophical point. So yeah, I think in general, the answer is yes. Yeah. As to how you connect construction models with cognitive pattern, this is not an easy question to answer. This is a very interesting question, but it needs very careful methodological design and stuff like that. But it is possible, yeah. Okay.
A second question comes from Gong Yichao about the first case study.
Okay, your talk is highly informative. Thank you, which is really broad. Okay, can each dot represent student distance? Each dot represents. Right, yes, okay, good. So they are definitely not linguistic metaphors because, you know, it's like I said, you can see it as an analogy, right? Because what you are saying, each dot represents students, you know, distance represents, so A represents B, C represents D, E represents F. The specific linguistic expression is not metaphorical, but these expressions, they converge to construct an analogy or a conceptual metaphor. So that is what I'm trying to drive. I was not testing the metaphoricity of individual expressions. It's more like, you know, using these expressions, you construct the whole teaching stimuli. The whole teaching stimuli is metaphorical, which is regression is, you know, using physical space to understand regression. Yeah.
Thank you for your answer. We have the third question from Li Peihan. Peihan, can you turn on your audio and video? You may chat with Professor Dennis Day directly.
Hello. Hello,
Hi.
Professor Tay.
Hello.
I'm a cognitive linguistics student, but I also have interest in machine learning. And nowadays, I used to design a machine that based on the pre-trained model and use unsupervised methods to deal with the metaphor. So I think whether your model like CO and CI, this model can be a good way to deal with those data, those language data, and have a good results, put them into this such a machine. And whether your pedagogy not only useful for student and teacher, but also for machine learning.
Thanks.
Thank you.
Yeah, thank you. I think I'm not saying that these techniques are useful for machine learning per se, right? So because what I'm talking about today is these techniques are useful for teaching machine learning concepts. So there's a huge difference, right? So the talk today focuses on pedagogy. So if you're talking about machine learning pedagogy, then that's exactly what I'm talking about today. So for instance, of course, regression is a very simple algorithm, right? So if you use things like clustering or, you know, association rules mining or PCA, that kind of stuff, right? It's a bit more complicated. But potentially, yes, right, if I ask you, if you know what is principal components analysis, right? I'm sure you do. So how do you use a metaphor to teach that? So that becomes a very interesting question, right? Can we construct a metaphor to teach people what is dimensionality reduction, you know, what is components and, you know, all that kind of stuff. So yeah, so definitely this, so the pedagogical framework I talk about today potentially is applicable to other target domains. But, you know, it's not really about the algorithm itself, the machine learning algorithm itself. Yeah. I hope that is.
Yes.
I hope
it will make sense. And maybe I can make another question related to the first one. That, you know, that in machine learning we use word vector to express different words. Word vector.
Yeah,
yes.
Yeah.
And I think. And what do you think that that if I use a metaphor like life is a journey, and these three words can be called into word vector, and what do you think that this number, this vector, can have some dimension to express that these three words have a relation in metaphor level? You know, just like how to connect this member, this vector, and the words and the sense of words.
This question is not really related to. It's a good question, but it's not really linked to the talk today. But okay, anyway, yeah. If you talk about vectorization, word embedding, I think a very important thing to bear in mind is you never isolate life as a journey. It's always a big corpus of text, right? So if you want vectorization to potentially capture life as a journey as a metaphor, if that's what you mean, then you have to look at the rest of your corpus, you know, to see to what extent they are metaphorical or not metaphorical. Because, you know, if you just use a single vector in a single document, it's not informative at all.
Yeah.
Right. So yeah.
Yes,
so
really. So just I want to have this connection, but I don't know how to make this the connection in what sense go to a more mathematical level. So I just think maybe your pedagogy method in this in this paper really has some help for me, or at least it has some light for me.
Maybe, yeah, I would say, I hope so. But, you know, right now I can't immediately think of how, but maybe we can continue the conversation, you know. I think you're onto something, but it's just it's not so easy to answer your question. It needs a lot of thinking. Yeah, thank you.
Thank you, sir.
Yeah, thank you.
That's all my question.
Thank you, Beihang, for your questions, and thank you, Professor Dennis Day, for your comments and answers. And now we turn to Liu Kun.
Hi, Professor Tay. Thanks for your talk. It's really enlightening. And I have some questions. Due to the cultural differences and individuality, some students may perceive a concept in a different way. For example, in your the metaphor, regression is fortune telling. If some students, for example, they are sleeping and they are confused with the concept regression, and they never heard the concept fortune telling before, so they may be even more confused and not excited. So are there any criteria to select appropriate metaphors for teaching machine learning to students? Yeah.
I think there's a misunderstanding here, right? This metaphor is produced by the student. So this fortune telling thing is actually an example of a student transforming regression from a target to a source. So first of all, instead of regression is fortune telling, it should be the other way around. Fortune telling is regression, because the student is using regression as a source domain to understand fortune telling. That's the whole the exercise.
Oh, thanks for your answer.
So that's okay.
Okay, I understand. I got it. And for my second question, because of the insecurity of metaphor, is there any need to combine metaphor with other practical practices to teach students? Yeah.
Well, in general, I would say that that's what my conclusion is trying to imply, right? Because, you know, there's a difference between a conclusion in the research and what to do afterwards, right? So the very limited study that I showed today concludes that yes, metaphor use when done too much may lead to insecurity, but what you do after that is a next step, right? So potentially, yes, to counteract this insecurity, we could combine, you know, metaphor with other things, but the question of what these things are is something that we need to explore further. So I'm not in a position to just say, oh, you know, let's do this or let's do that, because I don't know the answer myself, right? All I know is that we need to do something. Yeah.
Oh, thanks.
Hopefully you can be the one to come up with the something.
Thanks for your talk. It's really enlightening, and I'm very interested in this field. Thanks.
Yeah.
Thank you, Liu Kun, and thank you for your answers, Professor Dennis Day. I guess maybe next time for the teachers, especially because I can see that till now on the Wolf meeting platform, we still have over 60 participants, and most of them are teachers at different universities. So I guess next time when we teach the concept of regression model in different universities, some of the teachers will use what you have done in your first study, so that students may generate different understandings of regression model. That's great. And next, we have a follow-up question still from Tang Chuanhong. Can you see that in the chat?
Yeah, let me read it first. Yeah, I mean, what you pointed out is yeah, I would say in principle, yes, these are very general methods, right? You know, transformer, like, you know, ChatGPT itself is a kind of transformer architecture, right? So yeah, we can definitely achieve these things. It's just that it's not something that the typical cognitive linguist is necessarily interested in. So your question is a very computational linguistics kind of question, which is fine, right? It's just that what I was saying is in the context of discourse analysis, right? Currently, there's this there's a tendency to be critical towards over-reliance on computational methods, right? So of course you can still do it, right? It's just that what is the objective? So for example, if you do all these things, you can detect metaphors, blah, 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 blah. So what? What is the contribution, right? So, you know, are you going to replace all metaphor researchers or what? So it's a kind of potentially not a very clear-cut thing. But purely in terms of academic objective, what you mentioned are all possible approaches, right? And the linguistic measures you need is really something, if you know, then you already answered the question. So it's not something that I can tell you immediately because nobody knows what are the best linguistic measures to help us predict metaphoricity at this point of time. Okay. Yeah.
Thank you for your answer. Next, we have questions from Xiong Xingzhi. She will enter Beihang University as a doctoral student in the coming September.
Congrats. Okay,
Hi,
so
Professor.
hello.
Hi, Professor Tay. My name is Xingzhi, and thank you very much for today's presentation. And it's so glad to meet you. May I ask two questions? Well, firstly, in the second study regarding the created target to source transformation, well, how can we determine if the student have progressed from the surface to the deep and to the transfer stage? And I mean, what kind of assessment will be used?
Yeah, I mean, that's a good question. I mean, you know, for this kind of learning model, there is always this inherent kind of looseness about it, right? So you have this model, how it connects to actual practice is variable, right? So if you're a teacher, then it makes sense to think about specific markers, you know, or tests or criteria to kind of like, at least on the surface, try to establish that students have reached a certain stage, right? So in the original model by Hattie and Donahue, they didn't really specify what are the specific criteria for doing so. And the reason is because I suspect it's very context specific. So if you're teaching vocabulary versus teaching statistics versus teaching swimming, you know, every activity has its own benchmarks, right? So if you're asking me about specifically teaching regression, for example, right? Then I think what I was trying to show in my study was that the evidence for determining surface to deep will be the ability to infer parts about regression using the original metaphor. That means the input, right? Because surface is you're just learning a material, but deep is you can draw connections. And then from moving deep to transfer, it will be exactly what I showed, where the student is able to turn or transform the metaphor into a source domain for something else. So yeah, so your question points towards the more general need, right? To establish criteria to kind of validate this kind of learning model, which is a very good question, right? Okay.
Yeah, thank you very much. Your explanation is so clear. And the second question is that, could you please introduce more about the experimental instrument about the finger skin conductance response in the third experiment?
Right. So firstly, if you want to know more, you can feel free to read some of my papers. If you have the references, I can send it to you or whatever. You can email me. I can send you the references. So because I can't answer it very well in 5 minutes, right? So that will give you a good understanding. But very briefly, it's like a device. It's like just this big, right? Okay. So if you just search skin conductance or you search electrodermal activity, EDA, that's a more common name. Right? So electrodermal means electricity of the skin. Dermal means skin, right? So and you will see a lot of devices from different companies, right? So generally just like this, and it just connected to a pair of electrodes. The electrodes are attached to your index finger. Yeah. And then once you do that, once you start the device, it will start to register the skin conductance. And some devices can also register more markers like your skin temperature and so on and so forth. And the signal is transmitted to a computer, and then you can do all kinds of analysis. So that's the experimental instrument involved.
Yeah, I think this kind of experimental method is really interesting, and I'm wondering if universities in China have such kind of instrument to support us to do such kind of similarity experiment.
You got to ask Thomas, not me.
Okay, and actually I have another question. Well, what kind of theoretical progress does your research indicate as compared with the conceptual metaphor theory proposed by Lakoff and Johnson?
Yeah, like I said, it's right at the beginning, the whole idea is to try to move beyond looking at metaphor purely cognitively, right? And purely as a static structure. So conceptual metaphor theory, of course, is great, but one of the things that is often criticized against it is that it is unidirectional, right? So only source to target. So people are trained to think that I will have a concrete source domain. My objective is to map it to a target domain, end of story. But for instance, in my study too, I showed that that's not the end of the story. From source to target, and then with some mental gymnastics, the target, which is supposed to be abstract, but it can become concretized and then become another source. So that is one example of a so-called theoretical, enhancement, so to speak. And then the other aspect of it is, if we use metaphor in teaching, it's not just about cognitive transfer, it's also about motivation, affect, interaction. We need to consider those things as well.
Yeah, okay. Your explanation is very detailed and clear, and I believe I have gained some deeper understanding and gained some valuable insights from today's presentation. Thank you so much. Bye-bye.
Thank you, Xinzhi. So due to time limit, we have a final question still from Tang Chuanhong. Thank you.
Okay.
Say that in the chat.
Yeah, this is a good point. Again, this is an instance of the more general observation effect, or what we call the fact that when people know that they are being studied, they kind of respond, right? So I think what I can think of is there are two ways to combat this, right? Both of them are in the literature, right? So for example, there are empirical studies that show that if you let some time pass, people actually kind of forget that they are being observed, right? So in a lot of conversational studies, like doctor-patient communication, when you put the camera there, initially people will kind of be a bit awkward, but after some time, things tend to become more natural. So that is one of the most primitive ways to address this. That means, just give them some time. Another important way to do it, which is built into the skin conductance methodology, is that the baseline period, which is always say, right? So because skin conductance cannot be controlled, so therefore what you need to do is you got to make sure that everyone starts at the same point or similar point. And you remove, in your own words, right, exclude all these side effects or exclude all these so-called noise, all this anticipation, this anxiety, this uncertainty. You do so simply by asking them to relax for the first 2 minutes. Close their eyes, don't do anything. And the good thing is that you can actually monitor how it goes. If the subject is actually cooperating with you and not thinking about all these things, you will see a gradual decline, like I showed you. But in some cases, like what you mentioned, some subjects, they will be thinking about all these things. Then you will see that the signal keeps fluctuating and it doesn't go down. And in those cases, my advice is exclude the subject, because this subject is, like you say, very likely to be influenced by all these things. Yeah.
Thank you for your answer. Yes, the side effect is unavoidable, but it may diminish as the experiment goes on. Thank you. Thank you for your 2-hour hard work, Professor Dennis.
It was a pleasure.
So let's call it a day and wish you a very good afternoon.
Okay, same to you.
Thank you, Dennis.
Thank
It's
you.
a long Saturday morning, hard working. Thank you.
No problem. Thank you.
Thank
Okay.
you. I'll write to you later about your video recording after the talk.
Okay, thanks everyone. Good day.
Okay,
Bye.
thank you very much.